Greetings, everyone. All right, let's talk about transforming log graphs. But before we get to actually graphing the log functions, I want to go through the numerical understanding of what's actually happening here, because sometimes when we talk about the graphing transformations that we do, we lose sight of the fact that the things that we do graphically come from the numerical relationships that we're dealing with in the problem. And I want to explain that first to hopefully alleviate some confusion that might be there. So I'm going to deal with this y equals log base 2 of x first. Now I'm going to choose some x values that are easily done, or that we can easily compute the y values for over here. And then from there, we're going to see how this transformation, by changing x to x minus 1, how that affects the points on the curve. So let's start with an easy value. I can plug in 1 for x. Now remember, this means in my mind that my base is 2, and the answer is 1. I got to think about, what do I have to raise the power of 2, raise 2 to what power in order to get 1? Well, we should know that that's 0. And as we said before, the point 1, 0 is on all these parent graphs for all the log functions. Similarly, now if I tried to plug in 2, I got to think, well, what do I raise 2 to? What power do I raise 2 to in order to get 2? Well, that means I got to raise it to the first power. I'm choosing really easy numbers here because I'm looking to make a bigger point about how the effects of the transformation happen. Similarly, if I plug in 4, I'm going to raise 2 to some power, and that has to be 4. We know that's going to be 2. And I can continue this on. I would go one more maybe and raise 2 to some power to get 8. And that, of course, hopefully you know, is going to be 3. Now, when we're dealing with our transformation over here on the right-hand side, we're dealing with this new expression. Everything's all just about the same. We have the same function, log. We have the same base 2. The only difference is now we have subtracted 1 from x. And so I want to see what that does in the table. We should understand that that moves the graph to the right when we're plotting this. But why does it move it to the right? Well, in case you didn't know, hopefully this explanation will help get you an understanding. So what you want to do is start to think about, what value of x would I plug in here onto this x on this side for this new function, so that I would get the same input 1 like I had over here in the left-hand table. Well, I hope it's not too hard to figure out that x would have to be 2. Because if I plug 2 into my function over here, if I plug 2 in, 2 minus 1 is 1. And so then I'm evaluating log base 2 of 1, just like I was doing over here in this entry on the original table. And so by doing that, I hope that you can see that the output here has to be 0. Because now what I'm doing is I'm taking 2, I'm raising it to the power of y, and I got to get 2 minus 1. Okay? Because remember, I plugged the 2 into the function that we had up here, like this, plug that in up here, and I got 2 minus 1 as the argument. Well, what do I raise 2, to what power do I raise 2 so that 2 to that power gives me 2 minus 1, which is 1? Well, 2 to the 0 power equals 1, and so that's why I get this 2, 0 on my graph. All right, so the next one. In fact, I'm trying to force all the same y values out of this. I'm trying to get all those same y values back. What value am I going to plug in for x in my new table here so that my function that I'm evaluating will be log of base 2 of 2? Well, I hope that it's not too hard to see that it's going to have to be 3. Okay? Because if I plug 3 into the function up top, plug 3 in up here, 3 minus 1 is 2, And then I'll be evaluating the same thing I got over here, which will give me an output of 1. So in other words, because I'm subtracting 1 from my x's before I take the log, I have to add 1 to all the x's in my original table to get those original inputs. So instead of inputting 4 over here, I would have to input 5 over here, so that 5 minus 1 is 4. The log base 2 of 4, as we saw in the original table, is 2. Similarly, I'd have to plug 9 in for this last one, so that I would take 9 minus 1 to give me the 8, and then 2 to the third power would give me that 8. So the point 9, 3 is on the graph. So notice that all of the points in my original graph are now moved over, okay? This point over here is moved over 1 unit to the right. This point over here is moved over 1 unit to the right, and so forth. They're all moved over 1 unit to the right, even though it said in the parentheses x minus 1. Because in my new table, I need a value 1 unit bigger, so that when I subtract 1 from it, I get back the original values of x we had from the other table.